Hi, my name is Hans. I have two project proposals that I would like to present. Unfortunately, I will not be able to be here today because I have other appointments. As you'll discover at the end of this short video, I'm very busy on Mondays. At the very end of this presentation, I'll tell you a bit about how you can find me. My first project proposal is about the blockchain, which I'm sure many of you have heard about. It's a very broad project proposal. Both project proposals are very broad. This one is a joint proposal with Stefan Schmidt. Um, Most people have heard of the blockchain and the setting of cryptocurrency, which is one of the most interesting ideas in computing these days. And most people probably know of the Bitcoin, um, which is a prime example of cryptocurrency. And the way cryptocurrency is realized is through a distributed protocol called the blockchain. The blockchain is the data or the datum that is passed around in the blockchain protocol. And the claim is that the blockchain protocol guarantees integrity and secrecy and anonymity and what have you. And there's a lot of hype around the blockchain. Some people are now trying to use the blockchain technology for other means. In particular, there's a company called Scenario Podensk, that's trying to set up decentralized social networks using blockchain technology. And the idea behind the blockchain is that it constitutes a distributed sharing of information. There's no central authority. It is the blockchain, this piece of datum that evolves as the protocol proceeds, that guarantees that information is shared in a secure fashion. And in the good old days, when everything was centralized, you needed to rely on some clearinghouse. You needed to rely on a central server. That's no longer the case in blockchain protocols. The complication or the challenge is then that you have to establish this consensus by some other means, and that's what the protocol does. And as I've already hinted at, these protocols should guarantee several things. For one thing, transaction anonymity should be a property of the protocol. So if you want to spend money anonymously, you should be able to do so. And when you're talking cryptocurrency and in many other settings, say voting, non-repudiation is important. It's important that no participant in the protocol should be able to claim successfully that I never said this or I never paid for that. There's also authenticity. We want to make sure that if somebody claims to have sent something, then it was that somebody. If I claim to have sent you 5 bitcoins, it was really me, it wasn't somebody else. And then, of course, there's integrity. Integrity is really important to the blockchain protocols because this blockchain, this large piece of datum that contains information about the participants, that piece of datum needs to be a piece of datum that no one can tamper with. No one should be able to fiddle the blockchain, so to speak. And those are the properties that the blockchain protocol claimed to guarantee. But how, if we actually have an implementation of the blockchain, how can we actually make sure that it guarantees all these properties? It may be flawed. Well, we could run it, couldn't we? But we never know how and when the flaw, if there is a flaw, will ever show up. It might be better if we could check this once and for all. And it would be nice if we could find a nice programming model that could help us do this. And this is where I come in because I'm in the programming technology group. It would be nice if we could find a nice programming model. And there is at least one candidate. The scenario people have proposed a simple programming model that they say can be helpful in order to specify and implement the blockchain technology. And they've used it to design and implement their version of the blockchain, something that they call the R chain. But there's one thing that they haven't done yet. They haven't showed how this nice simple programming model can be used to guarantee that our chain is actually secure in the sense that it should guarantee secrecy, integrity, anonymity. It would be nice if we could check this once and for all. But there's a lot of scope in this blockchain proposal. What I'm interested in is finding out how one can actually program the blockchain and finding applications of the blockchain technology, but also, of course, linking this to concrete notions of security. Um, a good master's project is not one that just implements something without reflecting on what we're implementing and why. A project about this could try to use the programming model that Scenario came up with for our chain for a concrete setting, maybe a voting system or a social medium or some other concrete problem setting, and then we could specify that. It would also be interesting, if this sounds too large, to see how we could devise a simple method for analyzing security properties uh, in the setting of the blockchain, such that we could simply go through the code and see if there are any problems. And it would also be interesting to see if we could find a better programming model for the setting, because what we have now may be too complicated or may not be well suited. Um, what Scenario used is clever, but maybe there's more to it than what they argue. So this is a very broad project proposal. One can go in many different directions here. My other project proposal is about writing and analyzing parallel code. Um, One thing that we know from the world of sequential programming is that in languages like Scala and Haskell or F Sharp and the ML family, we have some very strong type systems around, and those type systems are very useful if we want to prevent certain runtime errors. The type systems are very strong, much stronger than what you find in the C-like languages, say. But if we consider parallel code, and there are lots of parallel applications, you also get other runtime errors that you could never find in a sequential setting, because there are runtime errors that involve more than one program component, and that may have to do with a protocol error. And this is also a cause of security problems. Here's a tiny example of what could go wrong. Suppose we have an application that runs two threads, two processes A and B. I have made up some communication primitives. There's one called receive and one called send. And suppose program process A and wants to receive something on channel C and bind it to X. And it gets that special something from process B, because process B is ready to send on channel C the number 13. Later on the channel C, process A is now willing to send out the truth value true, which process B can then receive. And then that of course all looks very fine. But suppose we do things in the opposite order in process A. That process A wants to send the truth value before receiving. Oops, that may not be so good. These two processes will be deadlocked. They're both trying to send, and they can never proceed. It would be nice if we could find some way of checking that. Well, of course, we could run the programs, but again, that may be costly, and we may never detect the error. It would be nice if we could check this statically at compile time. And one thing we can do is to assign types to the channels that we're using and check that we use them correctly, which is that things are sent in the right order. This is an idea that goes back to the early 1990s. The first session type systems, as they're called, were proposed by Honda and Cooper and Vasconcelos. And since then, there's been a lot of work on that. Here's a simple example of how you could do this with session types. Well, here's process A. Process A sends, process A receives on channel C something that it binds to X, and then sends the truth value true on the channel C. Process B sends the number 13 on the channel C, and then later on receives something on channel C that binds to Y. And given that things happen in that order, what should the type of the channel C be? And well, if we say that the type of a channel is an account of how things happen on that channel, the events that happen in the order that they occur. Then the type of C is, well, we can first input an int, something of type int, and then we can output something of channel or of type bool, sorry, on the channel, and after that, nothing more can happen. So that's one end of the channel. At the other end of the channel, things are dual, so to speak. Uh, First, we can output something of type int, and then we can input something. We can receive something of type bool, and then nothing more can happen. That's the other end. These types are what we call session types. And if you look very closely at these types, you'll notice that they are dual, as I said. For every int in the process A type of C, there is an out in the process B type, and vice versa. And then, of course, there's lots to think about, because now we can type parallel programs and we can type the channels. But sometimes we come across situations where we have two channels that perform the same communication but don't have the same description. Here's an example of that. The top channel has an input and of an int and then an output of a bool. Below we have a different channel that has a choice. We can either, that's represented by the OR, there's an OR in the middle. We can either input an int and then output a bool, or we can input an int and then output a bool. The choice is redundant, but that's because we're humans. We can see that the choice is redundant. It would be nice if we could check that these two channels really have the same behavior, because then we could replace one by the other. How do we do that? We know how to check that a program is well typed, but how can we check that channels in our parallel program have equivalent types? If we want to implement a type checker for our programming language, we should be able to check this such that we don't reject too many programs that are well behaved. And I think I have an algorithm that can be used to check this, but I haven't used it in a concrete language setting yet, and it hasn't been implemented. My burning question is, will this work, and how could we implement it nicely? And there's lots more to think about here. This is a starting point. And one thing that I would particularly like to find out is, if we take this approach, how can we live inside a nice, actual, maybe object-oriented programming language? So there's something to think about here. If you think that one or maybe both of these ideas are interesting, come see me. I'm in my office, which is 5234. Most days, Mondays, I'm usually busy with meetings and other appointments all day. Most of the days are a lot less hectic. If you want to be sure that I'm there, when you get there, then send me a mail message and we can make a concrete appointment. I look forward to hearing from you.